Hello everyone, this is Vishnu from Institute of Aeronautical Engineering. So for computer networks tech talk, I have selected in network intelligence control towards a self-driving networking architecture. So let's get started. So in the first place, why do we even need to develop a in-network intelligence system? So the current infrastructure, well, the current infrastructure, which the existing one, which is uh, it's actually not ready for the IoT devices or the demand uh, or the capabilities that the industry has seen for an IoT device. The network infrastructure which we had is not capable enough to uh, to com- comply the needs of the end user. We can say that. So with that and because of that and current generation in network systems are dependent on manual processes which restricted in poor scalability and robustness. um, the processes where the cyber security and all those operations are at present manual. So whenever there is a huge traffic or huge traffic in the network or um, the data packets are, I mean, the load on these systems, the servers, and all of that, the hardware, uh, all wasn't ready enough, and manual process in the sense the cybersecurity network, their operations are not automated, and uh, because of that, more manpower or yeah, more manpower was required to comply the needs or the uh, re- uh, proposed requirements, and since the hardware wasn't also ready for these kind of loads, it resulted in poor, I mean, it resulted in problems, we can say. So, and network being the backbone for IoT devices, the current generation network systems needed an upgrade. So, IoT devices, IoT itself stands for Internet of Things, where Internet is the main backbone for the to and fro data transfers. And so because of all these problems and the need of IoT devices resulted in a system which is capable enough to manage the traffic in the network uh, or without any intervention or human intervention. So this in-network intelligence system has been developed using machine learning. Moving on. So how IoT works. So IoT, as I said earlier, it's Internet of Things, where a device or a microcontroller uh, will be the heart of the system, and to which sensors will be connected, and these sensors will collect data, and the microcontroller which is on board convert will interpret this data and convert it into packets, and with the help of a transmitter these this data will be transmitted in a viable format. So that's why we need a microcontroller, so that the data can be pre-processed and sent via a transmitter. So and these transfers are done via network. So there is no radio like the one which our mobile phone we uh, make calls, and the other way, yeah, one is the radio and near field communication. It's um, well, near field communication, it got its very own disadvantages, because it will only work if we are in a close proximity to the main device, which is not uh, which is not at all which is not something that is required, or which is what we need at some times. So We use network for these operations for sending data. And why only we need data, and why can't we use microcontrollers to process the data? Well, they are not that capable enough to achieve processing or achieve or to be able to process data and uh, do something out of it. Something in the sense, some kind of analysis or any other operations for that matter, or running ML algorithms or DL, which is completely out of box. Like the current hardware is not that capable of handling heavy neural network tasks. Well, they can perform light work or light neural networks or small. We can say that not a dense network, to be precise, uh, which is not very dense. So a microcontroller can handle it, but deep neural networks and dense networks, all these for these kind of applications, microcontrollers are not at all suited, and we need to transfer data. So for that, we need networking. I mean, we are using internet because it's fast and we can access it from anywhere. So IoT devices are not only meant to transfer data but also to collect data via network. So if there is any command that has to be sent from the source or the main unit or the main control unit, so as to activate other sensors and deactivate some other sensors, or anything, any operation. So for those reasons, there is not only transmitting of data from the IoT device but also receiving the data so as to perform a specific operations. So moving on. So what are self-driving systems? So self-driving systems is a terminology which is actually used in automotive industry. So self-driving systems are those systems which perform operations without human intervention. Uh, they are intelligent enough to handle tasks which are completely different. So over here we are referring to the data packets that are delivered from the source to the uh, receiver or receiver's end. So, and this is tried to achieve by considering three use cases, which is in-network load balance, in-network congestion control, and in-network DDoS detection. So, load balance. Load balance uh, is nothing but the uh, load balance is required in places where uh, there are n number of users who are constantly sending the data. So that can be one case where we need to manage to send data as quickly as possible, and for that we need architectures which can actually divert and send data effectively and distribute the traffic among multiple available paths. So some of the architectures are the SDN architecture, Swan, um, Hedera, and so on. Moving on, congestion control. So congestion control, it happens when there is a lot of traffic which is passing through a single channel, or yeah, a single channel, but other channels are not that busy sending data. So for uh, during those cases we can divert the data packets to other channels so that there won't be any congestion, and the data will also get transferred effectively. and DDoS detection. So DDoS attack is a attack where the source data will be manipulated and the receiver will receive some other data which is not from the source. So this is nothing but a DDoS attack, and the system uh, is also intelligent enough to detect whether there has been a DDoS attack or not on any of the servers, because data travels from one server to another server, then it will receive to the end user or the control unit. So uh, DDoS detect. So it's uh, vital because there is a purpose that we have built the uh, infrastructure, but if you don't get the legit uh, data, then it's a complete waste. So in previous two cases, we have talked about how effectively we can transfer the data, and over here, with the help of, I mean, over here in this slide, we are stating that how real is our data, or over here we're not doing any error connections or something like that, but we are talking about completely manipulating the data which is out of proportion. So thank you.